This is question number 2. Okay, a multi-stage compressor takes in air at 1 bar and 25 degrees centigrade. This is the suction condition that is given. And compress and this pressure from 1 bar it is compress air up to 20 bar. The delivery pressure is given 20 bar. Now assume perfect intercooling and that the amount of energy rejected at the intercooler is equal to the energy rejected during compression due to cooling of cylinder. The compressor runs at the speed is given and is 900 rpm and the mass the delivers mass is 3 kg per minute of air. All pistons have a stroke equal to 170 mm. Okay, calculate the number one is index of compression, the number of stages if the temperature at the end of compression is not exceed. This is important. Temperature at the end of compression is not exceed 400 Kelvin. Okay, the temperature and pressure at the end of each stage, the total power input to the compressor if mechanical efficiency is 80% for each stage. Total power input means we have to, if mechanical efficiency is given, we have to find out first integrated power and then brake power. And cylinder dimension. If volumetric efficiency is 80%. For cylinder dimensions, we use mass per rate and volumetric efficiency formula. Okay. So first we find out the index of compression. For index of compression, it is given in the numerical that assume perfect intercooling and that the amount of energy rejected means suppose this is PV diagram. In this PV diagram 1 2 3 4 this is the cycle for LP compressor. 5 6 7 5 6 7 8 okay, this is the cycle for HP compressor. Okay, this is suction pressure PS equal to P1. This is intermediate pressure PI equal to P2 equal to P5. Okay, and this is delivery pressure P6 equal to P7. Okay, and this is a intercooler 2 to 5. This is intercooler. Okay, and this is on this diagram. This is 1 to 2. This is compress in the LP compressor. Okay, then 2 to 5 is the intercooler. 2 to 5 is the intercooler, and 5 to 6 compress in the HP cylinder. Okay, now we have to first find out the index of compression. For index of compression is given the amount of energy rejected at intercooler. The amount of energy rejected at the intercooler is equal to the energy rejected during compression due to cooling of cylinder. That is equal to the energy rejected during the compression process, that is 1 to 2 process. So first we find out energy rejected at the intercooler. The energy rejected at the intercooler is, and this is a constant pressure process. So we can write m dot into Cp into T2 minus T5. But for perfect intercooling, T1 equal to T5. Okay, this is T1. Okay, for perfect intercooling, T1 equal to T5, and okay, that is equal to energy rejected during compression process. The energy rejected during compression process is 1 to 2. So we can write gamma minus n upon gamma minus 1 into work done for compression process. This is the formula for energy rejected during compression process. So m dot r into T2 minus T1 upon n minus 1. But we can write this R upon gamma minus 1, R upon gamma minus 1 equal to CV. So this formula is gamma minus n upon n minus 1 m dot, this is CV into T2 minus T1. So in here we can also write you T1. So T2 minus T1, T2 minus T1 is cancelled, is cancelled. Okay, here is only Cp, this is cancelled now. The gamma minus n upon n minus 1, here is only Cv, this is cancelled. So we can arranging this term. This is gamma minus n upon n minus 1 Cp by Cv. Cp by Cv is called a specific heat ratio, that is called gamma. Okay, so again gamma minus n and gamma n minus gamma. By arranging n is equal to gamma upon gamma plus 1. So we get n equal to 7 by 6, or we get n upon n minus 1 is this 7. Okay, now this is the first answer, the number index for topic index. Okay, second we have find out the number of stages. For that the condition is given temperature at the end of compression is not exceed 400 Kelvin. Means temperature at the end of compression is not exceed 400 Kelvin. For it we have to find out the number of stages. So we can write RP stage. RP stage is equal to RP overall. RP raised to the power x is equal to RP overall. When we know that RP overall is delivery pressure upon suction pressure. This is delivery pressure upon suction pressure. What is the stage pressure ratio? That is P2 by P1. This is raised to the power x. But we don't know the number of stages. So we can write P2 by P1. P2 by P1 is equal to T2 by T1. T2 by T1 raised to the power n upon n minus 1 raised to the power x equal to this 20 by 1. But this T2 is maximum. And that's why we write here is maximum. Okay, therefore T2 by T1 equal to this equal to 20. By taking log on both sides, we will put in the values of n, and maximum temperature T2 is given. It is not exceed 400 Kelvin. This 400 T2. T1 is given 298. We find the number of stages is 1.46. That is 2. The number of stages is 2. Now this is the second answer. Now third, he is asking temperature and pressure at the end of each stage. Temperature and pressure at the end of each stage. What is the pressure? What is the temperature? Okay. For that, we first find out for perfect intercooling intermediate pressure. For perfect intercooling intermediate pressure is Ps into Pd, under root of Ps into Pd. So we get 4.472 bar. This is intermediate pressure, that is P2 equal to P5. And now next we find out intermediate temperature T2. T2 by T1 is equal to P2 by P1 raised to the power n minus 1 upon n. We know T1, we know just calculate P2, Pi is equal to P2, okay, and P1 we know 1 bar. So we get intermediate temperature is 369 Kelvin, and thus T2 is equal to T6, that is perfect intercooling, and T1 is equal to T5. T1 equal to T5, T2 equal to T6, and intermediate pressure is P2 equal to P5 equal to 4.472 bar. Now we have to find out the power input. Power input, so first we this is the formula for integrated power n upon n minus 1 m dot r T2 minus T1. This is for formula for LP compressor. Now we know that there are two number of stages. That's why it is multiplied by 2. And we have to find out the brake power. That's why it is divided by mechanical efficiency. Now put in the formula M, R, T2 and T1. We will get the brake power 17.85 kilowatt. And last we have to find out the cylinder dimensions. For cylinder dimension we are using the mass flow rate equations and volumetric efficiency formula. So this is again, this is the actual volume of air taken inside the cylinder. So mass flow rate at the suction conditions is or LP for LP compressor is P1 into V1 minus V4 upon RT1. This is when we are using this mass flow rate formula and volumetric efficiency formula, we have to we have first find the diameter of LP cylinder, diameter of LP cylinder, and then we will find our diameter of HP cylinder. The first diameter of LP cylinder is this formula V1 minus V4, V1 minus V4 m dot RT1 upon P1. Well, put in the values of m, RT1 and P1, we get V1 minus V4. Now we know volumetric efficiency. It is given 0.8. The volumetric efficiency equal to actual volume of air taken inside the cylinder, that is V1 minus V4 or V1 minus V4 divided by swept volume, that is VSL. Okay, that is without SL. The formula we get without SL, V1 minus V4 upon volumetric efficiency. It is given 0.8, it is calculated 2.56. From that we get swept volume of LP cylinder. And now it is easy. We have to find out the diameter of LP cylinder. For that we are using without SL equal to this pi by 4 dl square into L into number of cylinder into number of cycles. Okay, the L is given, that is 170 mm, that is 0.17 mm. 0.17 meter. Okay, so put in the value of V without SL, L, and C equal to N. Okay, it's equal to single stage. Okay, single acting. Sorry, we will get DL. We will get DL, that is 16.34 centimeter. This is the DL is okay. Now we have to find out the for DH. For DH, we are using mass flow rate formula. Mass flow rate of suction conditions of LP is M1, P1, M not equal to P1, V1 minus V4 upon RT1. And for this, this is P5, V5 minus V8 upon RT5. Okay, upon RT5. So we are using this formula. From that, we will get V5 minus V8 is equal to MRT. Now T1 equal to T5. So we can write here T5 equal to T1. Okay, so we will get MRT1 upon P2, because P5 is equal to P2 and T5 is equal to T1. From that we get V5 minus V8. Put in the MRT1 and P2, we will get this value. And now put volumetric efficiency for HP, that is equal to V5 minus V8 upon V dot SH. From that we get V dot SH, that is V5 minus V8 upon volumetric efficiency. We get V dot SH, and from that V dot SH we get diameter of HP cylinder. By using same formula, we will get diameter of HP cylinder is 0.0771. And now we can also calculate by using this formula. Okay, mass flow rate formula and volumetric efficiency formula.